Hello all. This is our third video for this sales forecasting. Okay. Let's continue with this video. So let's connect first. Uh, guys, in the in this use case till now, what we have done, we have started with the sales forecasting use case. Okay. Then we went through the introduction of this sales forecasting. After going through the introduction, we talk about problem statement, means what we are trying to do. We discussed that we will do like weekly sales. Okay, so we will do forecasting for weekly sales at different stores. Okay, so the target feature is the weekly sales column, which is the sales of a given department in given store for a particular week. Then we import libraries. First, we install this My Data Profiling for Pandas data profiling, which is useful to view about different columns. Okay, so we see that means it gives details how many unique values are there, a number of missing values, and different aspects of different columns we can see from here. Then we import other libraries like NumPy, Pandas for plotting. We import Matplotlib, Seaborn, and then we suppress these bondings. Then we import some other required like train test, split, cross validation, and grid search CV. This is for hyperparameter tuning. So after that, we have imported linear regression model, decision tree regression, regressor, random forest, and support vector regression from support vector machine. Then for tracking the performance of our model, means how our model is performing, we import some uh, errors matrix like mean squared error, mean absolute error, and R2 square. Then we did data loading and data set descriptions. Data loading, and after that, we have discussed about the data that this is the date column which we cannot provide to our ML algorithm. So we will extract day and month from here, and then we will drop this date column. Okay. So this is just to show the columns. Then we do data profiling and then create profile report and save this profile report to our system. So let's run cells till now. The cells are running. Just a second. Okay. So after this, we save this in our local computer. This pandas profiling. It is created here, so we can download from here. Okay. So then we from this pandas profiling we can see these points. We have already discussed, so no need to do it again. Okay. Then We then we started data pre-processing. So in data pre-processing, first we will deal with missing values. So we check how many missing values are there in our data. So these are the missing values in our data. Uh, we can see that these markdown cells have more than 60%, 54% missing values each. But here we cannot replace missing values in these columns with like a median value or mean value because we don't know that uh, about the events means are the events occurred or not. So what we will do for missing values, we will fill the missing values with zero. Okay. Uh, then what we do, we fill the missing values with zero. So sales data frame dot fill NA and then fill it with zero. Then again we check the missing value and then we can see that there is not any missing value. Then we proceed further and extract do some feature engineering by extracting month from date column. Okay, so for extracting month, what we do first, we convert the date column to date time format as it is not in date time format before. So we convert it. Then we create the month column from this date column. So it says data frame dot dt dot month. Then we look at our data. Cells in tandem. Then fill with zero value. Then we check that no missing value is left. Then we extract, convert date to date time format and create month column. Then we see the first five rows of our data. So you can see that now month column is created on the basis of this date. So month column is added. Now we do some EDE part. So we check how stores are distributed based on type means for type A how many stores are there, type B how many stores are there, and for type C how many stores are there. So this part you can see from my previous videos. I explained them in very detail there. So this is the distribution. Then we create the plot for the distribution and proportional distribution, and this was the plot. This. So type A has 48.9%, type B has 37.38%, and then type C scores are 13.3%. Okay. Then after this, we check that is the size of the stores related to the type of the store. So we can check that yes, the type and this code you can see from my previous video. Okay, I am not going in detail in this. So here we can see that yes, type A has the higher size than type B, then type C. Then the next question was, does the larger size store have higher weekly sales? So we create a plot with type and weekly sales. So clearly, type A has higher sales than type B, then type C. Now, question put is there a strong positive correlation between the size and weekly sales of a store? So, to check that is there any positive correlation between size and weekly sales, we have created uh, a scatter plot. Okay, so in this scatter plot, we keep size here and weekly sales here. So you can see that it is approx linear only. Means it is not like any line like this. Means if size is increasing, sales is increasing. That is not the same case. So that we have observed and discussed in detail. Then how does each store perform on the basis of weekly sales? We have done this and uh, we saw that like like it is depend on the type only. Like if any store belongs to type A, it has higher sale than compared to type B and then type C. Some one or two exceptions are there. Like here, type B is having higher sale than type A. But uh, rest is most of the type A store have higher weekly sales. Okay, so after this, we have checked does the weekly sales for each department vary with the size of the store. So we have created the box plot and check the weekly sales for all departments. And y-axis we keep department and on x-axis we keep weekly sales and then we group them by the type. We saw that sale of each department is also mostly depend on the type. Means if department is in type A store, it has higher sale. If then in type B, it has lower sale. Then in type C, it has lower sale. Okay, so we can clearly observe that department belonging to type A store have the highest sales record. Then this I have done for myself. You can it is just another columns. Okay. Then do the holidays impact the weekly sales of the store? So we will check that if there is holiday, what is the effect of that in weekly sale. So we run this and we can see that there is slight increase in sales. Okay, not much, but yes, there is slight increase in sales if there is a holiday in that week. So this we can observe from this box plot. After this, we check how does the weekly sales vary for each month. So to check how to check how does the weekly sales vary for each month, we have created the plot between for month and weekly sales. So here we notice that December have slightly increase in the sales. Means December has the highest sale, and in January we have slightly lower sales, and the remaining months have like say approx same sale. Okay, there is not much variation. So we discuss about it. Is what may be the reason for this. Then we go through the does the store size has an effect on the weekly sales of each month? So means is there any effect of store size on the weekly sales of each month? So we run this also and we notice that yes, type A store has higher sales in every month than type B and type C. So we concluded that a larger store have higher sales each month than a smaller stores. Now, post data processing and analysis. This was our easy part. Then we'll go to post further. Okay. See, see first, few rules, not an issue. Then we do the encoding of categorical data. So here we do the encoding of dummy encoding of type column. We have done the dummy encoding of type column. That is one hot encoding. And use drop first. I have explained in previous videos what is drop first and why we use it. And then we keep it type int so that we won't get error later while applying machine learning algorithm. Okay, so let's run this. This was, if you see this type column, actually three values was there in type column. Here type A, type B, and type C. So now two columns was created, type B and type C, because we use a drop first. Otherwise, three columns will be there. Okay. So after doing this dummy encoding or one-hot encoding, we extract the day feature from date column. We discussed why we did this. Then we again see our data. Now all the required features are extracted from date column. So we remove a date column from our data. Then this is holiday feature is in uh, true false. So we converted them into numerical, like 0 for false and 1 for true. And then we run this. Okay, now our data is post processing is approx done. So now we split our data. Previously, like for splitting, first for splitting first we create feature matrix X by removing the target value. Okay, and then we create target vector. Okay, and then we create train test and validation. This validation set we have created for because previously in our last video we have not created, but now we mainly means we are doing this video for discussing the Optuna hyperparameter tuning. So for this we need train, then test, then validation, and then we do uh, apply on test. So we first we like do train test split with test size of zero point 0.3. We keep random state so that our split will be same every time. So we done this. Now we created from test set, we created well test set and validation. Half value is 50%. So we run this. Now we check the shape of train test. This time it will be less than this. Okay. Okay. So this these are the values. Now model development and evaluation. Now we will jump to next part, that is model development and evaluation. So for model development, we will created one function to for the score, and the name of this function is display scores. Okay, so we run this. In this, we take as input as scores and then created the RMS, calculate the RMS value, and then we print all RMS scores, then take the mean of all the scores, and also check the standard deviation in between the scores to check how our model will perform on unseen data, or also how our model is performing. Then we created a baseline model. Just a second. Okay, we have done all the successfully. Then we created a baseline model, and we do cross validation. Okay, and for estimator we keep a baseline district regression, then x as a x plane and y as a y plane, and do cross validation of 5 and scoring negative mean squared error. So we run this and display the scores. So these are the values of RMSE for 5-fold, and this is our mean value. So after that, we have created a decision tree. Okay. And then same thing, we have done cross validation for 5-fold, and then we display the score. Let it run. See, in this linear regression, the average score was 21,500 and something, and here it is 5,400 and something. So RMSE value is decreased 4 times. Okay, approx 4 times it has decreased. So we concluded that decision tree was performing better than a linear regression. All this part we have discussed in our previous videos in detail. I am just going through it. Then we created a random forest model, uh, and we see that it runs for 5 minutes. I will not run this time. And then, sorry, for 3 minutes it has run, and then we get the score, and it was even lower than the decision tree, and it's come out as a best performing model. Now checking the feature importance. So for checking the feature importance using random forest model, we fit the random forest model on our training data, and then we use to retrieving the feature importance. We use feature importances. So base random forest dot feature importances, and it gives the importance of each feature. Okay, then we print the feature importance in decreasing order for each feature. So we here we zip the feature importance with column names and then sorted in increasing order. For that we use reverse equal to true and then print. So we can see that department has highest importance 53.35%, size has 18.73% importance, stored this much, CPI this much. So feature importances are organized in descending order. Now we plot the feature impedance. So we have created the bar plot using Snowflake. So here we have done this. I will not run this code again. That particular code. Okay, then we find out that these are the I will keep only six most essential features. So we created X train essential from X train. Okay, and then again we run our linear regression decision tree and random forest model, and then we find out that RMS there is even though we are using now only six features from complete data, our model performance is still the same, and even our random forest is performing better than before. Okay, so this value is the best value we have received till now. So this was the model comparison. So baseline model, we have a random forest with RMS value 3997, and with essential features, it is even more, reduced more, and it gives the best value of RMS. Then we do hyperparameter tuning. So in our last video, uh, we use in our last video we use grid search for doing hyperparameter tuning. Okay, so we have done grid search. For doing grid search, first we created parameter grid means for what features we want to do hyperparameter uh, tuning using grid search. So we have done this for n estimators. We keep it 10, 20, 30, max depth, none, 2, 3, 5, and max features like this. Then we create temporary random forest regressor. Okay, and keep random state as 0 and use all CPUs. And then we do grid search. For this we will input the model parameter grid and scoring method and number of nodes we use for cross validation into grid search. So for grid search we use estimator parameter grid scoring and how much cross validation we need to use, and we use all the CPUs. Then after then we do this grid search dot fit. Okay, and it took 15 minutes, so that's why I am not running this again because I have already done this in our last video. Now we calculate the best IMSC score found by grid search. So to find the best IMSC score, we do research dot best score underscore. Okay. So this gives the best score from this grid search. So then we find the hyperparameter value. So grid search dot best params. So this best params gives uh, max depth. Okay. So max depth as none, max features 4, and number of estimators will be 30. So we use these hyperparameter values in our final model. Okay. Then we do this for our final model. Okay, now since we have done, we have taken essential features from our training data. So same thing we need to do with our this test data also. Okay, and same thing we will do for validation also. So for validation also we will take important features. Okay, just a second. Okay, then okay. So now what we will do, we will install this Optina. Okay, so this install Optina, then import Optina. We will just we have installed Optina and then import Optima. Okay, so now we will define objective function with input as trial. So we have objective and input will be trial. Okay, and then we suggest number of estimators using trial. So trial dot suggest and we mention estimators and keep it like 10, then 3, and I'll keep the step size as 10. Okay, these are the number of estimators. Then, then what we do, uh, we suggest max depth. For that we do trial dot suggest in and max depth, comma. Okay, so for max depth, we will use suggest categorical. Okay, and means int we use if we want to give all the values between these two ranges. Okay, and categorical if we want to suggest a particular value from the list of values. So suggest for okay, so max depth and then we provide a list. Here we keep 5, 10, 20, and 30. After max depth, we have min samples. So trial dot suggest minimum samples in split. So we will keep between like 2 to 20. Okay, trial dot suggest in min samples split and keep it between 2 and 20. Okay, then we do like min weight fraction leave. So min weight fraction leave. Okay, so trial dot suggest and then since we are doing fraction part, then we use uh, uh, like float. Okay, suggest and this should be trial only. It will be between 0.0 to 0.5. 0.0. Then next features. And then next features will be trial dot suggest int okay, or you can say categorical. Because we are using we will use square root and log to also. So categorical and then just first first we have square root. Then we use log 2. After that we use zero point 0.5 and zero point 0.8. So what this suggests categorical to, it will take values. First it will take square root, then it will take log 2, then zero point 0.5 and then zero point 0.8. Okay, and after this max features, we have max lead nodes. Okay. Trial dot suggest categorical float and we keep max we float as 20, 50, and like this. Okay, so I will keep for now 20, 50, 100, and okay, then we uh, we do minimum impurity. Okay, so trial dot suggest float minimum impurity decrease. It means how much impurity should be decreased at each split. Okay, so 0.02, 0.1. So we are the like we create a random forest regression model and store in model. So after this, model equal to random forest. We have random forest regression and then and estimators to estimator. Okay, and after this we have x depth to x depth. After that we have minimum sample estimate sample estimate. After this we have minimum rate fraction. Okay, then we have max features, max features. Then we have max leaf nodes, max leaf nodes, and then have minimum impurity disease. Minimum impurity disease. Random state we will keep it as 0 and use we keep it 0 for reproducibility and jobs. No minus one. Okay, so this we have done. We have created model also. Okay, Now perform a five-fold cross validation using model. This we will not do, okay? Because if we will start doing five-fold, uh, then it will be very computationally heavy. So we will keep it simple only. So then uh, this will fit the model uh, on explain essentials and criteria, right? So model fit explain essential comma criteria. Okay, and then we do negative. I will then for prediction we do fit on see on essential. Okay, and then we do prediction on validation. That's why we do validation. Okay, so we do model. Model dot predict model dot predict uh, x prediction essential. And after this, we calculate RMSC value for uh, on the prediction value. So NP dot square root the values NP dot square root mean square error, and here we keep values y value y validation and y validation predict. Okay, and then we return RMSC. So this is our complete function. So like this we will do, and then run this function. Okay, and after this, what we do, we first we print uh, Optuna hyperparameter tuning start message, and we like we print start Optuna hyperparameter tuning. Then we create steady equal to Optuna dot create steady, and we give direction like we need to minimize error. So we will keep it as minimize. Then steady dot optimize, and in study dot optimize we provide objective and number of times. So we will keep it like 15 this time. Okay, then we find out best RMSC score like study dot best value and then best parameters. So run this. Okay, so it will be the output will look like this. So for trial 0, we have this much RMSE value. For trial 1, we have this much. And Optuna is more like robust than Great Search CV because it look at previous values also. Okay, so to see here this RMS value increase, so it will give you the lowest. I think this is the lowest. So best RMSE score is 16526, and best parameters are N estimators 30, max step 10, minimum sample is with 20, this much, max features this much, and this much. Okay, so within 1 minute 21 seconds, it has done such a great job. So we have found the best hyperparameters. See, if we have done this uh, here, like with our research. So with grid search, it will take some time. Okay, so it will take 15 minutes, and then it will give best parameter. Here we do uh, study dot best parameters. Let's see the this standard documentation also for this Optima. Key features. So these are the key features for this. Also, this Optima has like dashboard also. Okay, and we have Optima Hub, like it is a feature sharing platform for Optima. So these are the things like for examples, like defining objective function, installation, dashboard. This is for Optima Hub. Okay, and it has integration with like XView, TensorFlow, Keras, Scikit-learn, PyTorch. applied GVM also. So Optuna is a framework agnostic. You can use it with any machine learning or deep learning uh, framework. Okay, this is the thing. Okay, so just a second. Let me check. So this is the now we will create final random forest with these hyperparameters. So random forest regressor. Okay, and then we provide the random. Okay, so this is the final random. This here, language is only. Should not be like explain. Okay. So remove this and now run this for the end of the next leaf node. So for we can see here it is next leaf nodes. Okay, so we will change here this successfully. Now we will make prediction on both our training and test set. So y train predicted is final random forest or dot predict x train essential. So this will on fit with it on. So if actually we have created here, but we have not fitted. Okay, so fit it here. This so we will fit this. Okay, it unsuccessful. Now we will do let's do essential. Now making prediction on test set. So X test essential. Okay. So now we will create data frame actual test set values. So we are printing some values like these are the actual test set values like test and these are the predicted values. Okay, this is the actual value. 24,000 and this is the predicted value. Okay, our model is making a good prediction. Okay, so now uh, see RMSC on train and test. 1287 and 3261. You can see that this RMSC value on train and test is like there is not much difference. Okay, so like our model is not overfitting. Okay, so we get RMSC score of 3261. This 3261 we get with like that great search, but now we are using Optuna. It has reduced a lot. Uh, like this. We can calculate other some values also, and then we create a plot training and test also. Okay, so this is our complete code for sales forecasting. Okay, so this is the conclusion. Like we have seen in depth various features in the data. We have studied their characteristics and their distribution also. We went through extensive and thorough data analysis process. Means the part we have done in very detail here, and these are the you can pause your screen and then add the okay. So thank you guys. This is all for this use case. In the next video, we will start with the GCP.